In this video, we're going to be talking about a unit of concentration called molarity, as well as dilutions. You're probably going to need a calculator if you want to follow along and try these on your own. Periodic table for that would also be helpful. Once you have your stuff ready, let's go. Okay, so one of the vocab words that you had to define was concentration, which is just how much of a substance you have dissolved in a solution. A very common unit of concentration that you use in your day-to-day life is percent mass. If we look at, for example, a bottle of hydrogen peroxide in your bathroom or wherever you keep that, it says 3% hydrogen peroxide. What that means is that for every 100 grams of solution, 3 of those grams are hydrogen peroxide. So that's one you use on a day-to-day basis. But in chemistry, the unit we use is called molarity. It's based, of course, off of moles. That's why it has the mole phrase in it. Molarity is the number of moles of solute divided by the volume of the solution in liters. So here you have to be in liters. Milliliters is not good enough. One thing I should point out is that you want to use the volume of solution, not the volume of solvent. The reason why is because when you add something in, and we're usually going to use water, so when you pour something into water, that's going to raise the volume of the solution for most substances. So we want to make sure that it's the total volume of everything, not just the water. Right, but pretty simple 3-variable equation. You figure out the number of moles, you figure out the volume, and you get your molarity. So let's try an example of this. We want to make 335 milliliters of a 0.2 molar solution. Remember, molarity, whenever you see that, that means mole per liter. So we'll set up our equation, right? Molarity is moles over liters. We're given the concentration. Our concentration is 0.200, right? And I'm going to put mole per liter for my molarity, equals, we don't know the number of moles, so that's our variable. Our volume of solution is 335 mils. There are 1,000 milliliters in a liter, so this is 0.335 liters. From here, all we do is we plug in, is we just solve, right? I want N by itself, so N is going to equal 0.200 mole per liter times 0.335 liters. Liters cancels out. And we're going to wind up with 0.067 moles of NaCl. So that's how many moles we need to make the solution. But I didn't ask for moles, did I? I asked for mass. I want grams. So now we just have to do a mole conversion. Right, so 0.067 moles of NaCl over 1. If we're going from moles to grams, we're going to put moles on the bottom, so 1 mole of NaCl. I'm going to want its molar mass on the top. The molar mass of sodium chloride is 23 plus 35.45, or 58.45. Moles cancel. And this gives me a final value of 3.92 grams of NaCl. So the way that I would go about making this solution is I'd measure out 3.92 grams of salt, pour it into my container, and then I would add enough water to bring it up to 335 milliliters, cap it, and invert it a few times in order to make sure everything fully mixes, and that is a 0.2 molar sodium chloride solution. Right, so if you were able to do gas laws, this is no different, straightforward calculation. The other type of calculation that we're going to need to be able to do is what's called a dilution calculation. In a dilution calculation, what you're doing is you are adding or removing water to change the concentration. Right? So if we are diluting, if we add more solvent, the concentration goes down. Right? So concentration and amount of solvent are inversely proportional. If we remember from our gas law unit, if two variables are inversely proportional, we multiply them, and that will be a constant. So our equation for this is going to be M1 times V1 equals M2 times V2. Molarity 1 times volume 1 equals molarity 2 times volume 2. The number of moles in the solution aren't going to change. That's why this works. Now, the good thing about this is that V can be any unit you'd like. It can be liters, milliliters, teaspoons, drops, doesn't matter. As long as they're the same, just like they were in Boyle's law, this process will still work. All right, so what we have here is we have 1,500 mils of water being added to 300 milliliters of a salt solution, and we want to know the new concentration. So I'm going to go through. 1,500 is not a volume that I'm going to be using. My initial volume is 300 mils, right? That's what I'm starting with. My M1 is 2.5 molar. Now, this part, I kind of put this in to be a little bit tricky, right? We're having 1,500 mils of water added. So what that means is that V2 is equal to 1,500 plus 300, or 1,800 milliliters, right? Because we're adding the two solutions together, we add together their volumes. So the final volume is 1,800. Now, if I said that we wanted to dilute it to 1,500, we just use 15. All right, so again, we plug into here, M1, V1 equals M2, V2. So 300 milliliters is our volume. Our initial molarity, 2.5 molar. That will equal M2, which we don't know. V2 is going to be 1,800 mLs. Right, we'll solve. So M2 equals, and I'll just shortcut a little bit here, milliliters will cancel. So we're going to get 2.5 molar times 300 over 1,800. And that will wind up giving us 0.417 molar. Right, so if we add 1,500 milliliters of water into this solution that we started with, we're going to wind up at 0.417 molar. We add water, the concentration goes down. If we remove water, concentration will go up. I will see you guys in class.